All right, boys and girls of all ages. So I felt compelled to make this video, particularly because um, when I took exam FM 2.5 years ago, I think it was 2.5 or 3 years ago, 3.5 years ago, I think 2.5 years ago. The one thing that really surprised me is the amount of amortization of bonds questions that was on exam FM. And I actually asked ChatGPT, was curious what it would say, like, hey, why is this the case? Why does exam FM, and particularly the SOA, who writes the exam FM Society of Actuaries, why do they emphasize this? And ChatGPT, I don't know if it's correct, but it gave me a very plausible answer, which was, well, when you do a lot of modeling for, like, insurance reserves, um, and just in general insurance pricing and reserve modeling, you really do have to not literally treat, work with bonds and amortization of bonds, but it's the same kind of logic and reason. You want to basically treat things that behave like a bond as a loan, and you want to know kind of loan information, interest owed, outstanding balance, etc. Right. So one thing I want to make clear, I'll make put this as a comment in the video prior to this. On exam FM, there's actually weirder notation and terminology for amortization of bonds, particularly if the bond is bought at a premium, then the principal repaid is called the amount for amortization of premium. And the bond is bought at a discount, then the principal repaid is called the amount for accumulation of discount. Gotta be careful. I'll do an example to illustrate. You really have to be careful that they'll give this to you as a positive quantity, but the principal repaid, if you buy the bond at a discount, is negative. So if you're going to use your principal repaid formula, you gotta make sure you have a minus there. Okay. And just a reminder, so we had before, when R is less than G, same thing, literally the same thing. FR is less than CJ, then the bond is bought at a discount, and this is negative. If R is bigger than G, same thing, exact same thing. FR is bigger than CJ, this is positive, and the bond is bought at a premium. So, yeah, so this here is telling you exactly that bond is bought at a discount, principal paid is negative, except at the end. Um, if FR is bigger than CJ, if the bond rather is bought at a premium, then principal paid is positive. Actually, it's a little weird because on exam FM, they don't include the C in this formula technically, which is, yeah, a little bizarre. I guess it's sort of kind of like how accountants think, but we'll get to that later. So anyway, yeah, now that that is out of the way, I want to do some more amortization of bonds problems. These problems get really tricky, and you really have to really be careful in these problems. Um, uh, me personally, I didn't get a lot of these problems. I skipped them because they were really a little tricky, and you got 5 minutes to do a problem. So I did everything else, and I did it very well. Got an 8 on exam FM, and then I went back and I think I tried to do some of these problems. I don't know if I did them all right or even did half of them right. So yeah, in that sense, I don't know how important this topic is in the sense of, to me, it's kind of these tricky problems you skip, and a lot of them are tricky, but maybe you think they're easy, and maybe therefore you can get these problems right, and that might be the difference between passing and failing. Maybe something else you find very difficult that I found very easy. Okay, so I want to start off with a very useful formula. There's a lot of useful formulas, or a few more useful formulas than what we've talked about. And the first useful formula is the formula for the amount of discount slash premium that the bond is bought at. And um, so I'm sorry, this should be a plus here. I guess I can actually fix that real quick. So just bear with me a second. I think I'll just fix it once and then, well, clear that. Uh, works, doesn't give me a problem. You never know. Ah, it worked. Well, okay, so okay, so yeah, this is the price. Usual formula, discount your or present value of your coupons, FR, discount your redemption by end period bond here. Okay, so again, this should be a plus here. Just plug in for the formula for A and J, 1 minus Vj to the n over J. All right. And yeah, just factor basically FR minus CJ. Remember BJN is just one uh well sorry, you just all you do is factor basically factor this out and you'll see that I may not factor it out, but basically if you distribute here, you see you'll get this. And this is quite useful, very easy formula to use. And lo and behold, this is A and J, 1 minus Vj to the n over J. So yeah, again, if you have any doubts, just factor or foil this rather. I keep saying factor, foil this, and you can see you will get this. Yeah, I mean, there's really nothing. Just foil the FR, it's FR over J, 1 minus Vj to the n. And then take this minus CJ times this. And yeah, you'll get to see you get the J's canceling and yeah. So all right. So yeah, so particularly if the bond is bought at a premium, this gives you the formula for price minus redemption. So this will be positive because what it means to be bought at a premium. And if the bond is bought at a discount, this is going to be the redemption minus price. That'll be positive. All right, so easy peasy example. This example, you don't have to be careful with minuses, but the example I will do next, you do. Otherwise, you're going to get this wrong. So let me try to do this very quickly. Ain't. Okay, so you got a 40-year bond. So all these examples I'm going to do are taken from the SOA sample questions. Um, and yeah, so you got a 40-year bond purchased at a discount. Annual coupons, the amount for accumulation of discount in the 15th coupon is 194.82. So again, this problem you don't have to be careful, but I would in general be careful with signs. It's good practice even when sometimes you don't have to be. So in other words, the principal paid is minus 194.82 after the 15th coupon. After the 20th coupon, the principal repaid is minus 306.60. Calculate the amount of discounts that the bond was purchased at. Okay, so yeah, so with this problem, really just the only reasonable thing to do is use what we're given. We're given, well, had here minus 194.82. Principal were paid 15 coupon, and the formula the formula we have from before for principal were paid is F R minus CJ VJ. Why I write out with 1 over 1 plus J to the N is 40, number of annual coupons, minus T, which is 15, plus 1. All right, I'm also given this. All the information I have, these two things. Well, and bought at a discount. I have N, but yeah, I think I did a problem like this before in the prior video. It's fine. But the point here is this is good information because I can divide both sides here, right? And start solving for particularly J, which is good. That's a start. That's the only reasonable thing to do. So here, so yeah, I'm just same formula, T equals 20. So here, if you forgot your minuses, you divide. That's fine, doesn't matter, because divide minus by minus, same thing as dividing plus and plus. But again, good habit to be careful with signs. 40 minus 20 plus 1. So this is 26. Uh, and this is 21. Yeah. So yeah, divide one equation by the other. And the conclusion is that 194.82 over minus 306.9. The FR minus CJ's cancel, and you can check. You're going to get 26 minus 21 is 5. Let's just say 25. 26 minus 21 is 5. So 194.2 over 306.9. Raise this to the 0.2, 1 over 5. All right. Right, so that's what 1 over 1 plus J is. So do 1 over minus 1. And we get J is 0.09. And we can store this. All right, this is great news because, well, what do I want? I want the amount that the amount of discount the bond is bought at. So I want CJ minus FR, A, and J. So I have N, I have J, that's good. I just need CJ minus FR. And if you think about it, I can use either one of these to solve for that because, well, just plug in J here or here and multiply by 1 plus J to the 26, or 21, and you can solve for it. So I'll do that right here. Right, this is going to tell me that, let me move this to the right, give me room, nicer. Yeah, and you can use this one just as easily, but yeah, I use this, did I make a boo-boo here? No, I did not make a boo-boo. It's 194.82. I thought I had 192.82. Uh, okay. Yeah, 194.82 times 1 plus, well, 1 plus j is 1.095. To fifth equals FR minus CJ. So let's just multiply both sides by -1. So it's CJ minus F. Okay, and what is this? 1/5 times 194.82. 306. Yeah, 306. That should be to the 26. 20, it's 26 here. That, sorry about that. Like a weird number. 1 plus, we call 1 raised to the 6 times 194, 82, 2026, 206, 206,242. Yeah, let me. Yeah, I think if you do 1.095, you get 206,253 off by like 11 cents, or it doesn't matter. Um, okay, this is great because now we're basically done. Again, go back to this formula here. The answer is, and I'm going to store this in a 2 spot. Uh, really awkward. Right. So the answer is CJ minus FR. A 40.095. And do you have any doubts on anything I'm doing? You can check the answers in the sample SOA solutions. Again, everything I'm going to do from now on for these examples are just the sample SOA problems. Yeah, and this is 2062. We just solved for this. 2062, 2, a 40.095. All right, so yeah, this is payment 40, and we call 1 times 100. That's interest. Compute present value 21,130. And lo and behold, that's the answer E, 21,135. All right, so easy peasy. So actually probably a little easier problem, but yeah, you got to be careful. Your minuses. So you're given following information about a 20-year bond with face amount, annual coupon rate of R, payable semi-annually. I never understood why they say that. It makes no sense. But it says semi-annually, so it's semi-annual nominal. Um, Redeemable at par. Yield rate semi-annual 7.2%, so it's nominal semi-annual. Find the solution here. Let's go. Amount for accumulation of discount in the seventh coupon is, so after seven, basically principal or paid at T equals 7 is minus $4.36. Calculate R. So yeah, this is really, really quick. Still illustrates the idea. Gotta be careful. And I'll do it where if you're not careful, you get the wrong answer, though they're nice in that you don't get any of these if you do this without the minus $4. Without the minus sign, you don't get any of these answers, so you know you did something. Okay. New save. All right, so yeah, there's really not much to do. You just plug in for this here. Okay, so same formula. Plug in for principal or paid. Go back and check. So minus $4.36 is principal repaid after 7 coupons. And the formula there is the face amount. So it does not say there's a different redemption. So you assume the face amount is redemption. So it's 1,000 R minus, take this over 2. You probably don't need to use calculator for that, but 0.072 over 2. Again, nominal semi-annual. The actual 6-month yield rate is 3.6%. 1,000.036. Uh, 1 over 1.06, your present value factor, and that's 40. 2 times 20 minus 7 plus 1. Second, going when the pen does that, but better. Okay, so easy peasy. Figure out what R is. I won't do anything. I'll just pop in calculator. So 4.36 times 1.036 to the 34. All right, 14.51. Well, actually, I will. So, and I'll factor a 1,000. So minus 14.51 is 1,000 R minus 0.036. So yeah, let's multiply both sides by minus 1. So that means it's going to be 0.036 minus R. So divide by 1,000 for the minus. Now I'm going to subtract by 0.036. That's going to be minus R, or what I'm calling R, the actual 6-month coupon rate. You got to multiply by 2 because they want the nominal semi-annual 6-month rate. So lo and behold, that's the one of the answers. 4.3%. So it's C. So if you screwed up the minus signs and you had it like before, but with R minus 0.036. So let's say you did this. Let's say, I want to be clear, you don't do this. This is wrong. Let's see what happens with R minus 0.036. So you do 14.51 over 1,000 plus 0.036, 5%, and that's not here. Well, I forgot to multiply by 2. Well, that's 10.10%. That's not nowhere near anything. So you get way off, something way off if you forgot the minus sign. So don't forget the minus. Okay. So another concept that leads to a formula that pops up often, and apparently ChatGPT told me this is very important conceptually when you do later modeling for insurance. When I say later modeling, I mean for like long-term actuarial mathematics, short-term actuarial mathematics, and exam fundamentals of actuarial mathematics. Same thing as if you're CAS, Casualty Actuarial Society, Mass, Mass 1 and 2, maybe just Mass 2. But anyway, so let's go back to what let's go back to what outstanding balance really means. So remember, assuming we're not at the end, the coupon is just FR, or that's your loan payment, thinking of a bond as a loan. It's just your coupons. Right? So your new outstanding balance is how much your old outstanding balance grows by minus how much you pay. Right? You owe OBT. Now you owe OBT 1 plus J before you make a loan payment. Well, after your loan payment, well, you subtract that. Okay? Now, what we did before was solve this recursion, but we solved it going all the way back to our initial condition, which, of course, OB0 is the loan amount. At the beginning of the loan, you owe out. So that's how much you owe at time 2. What's important for these problems, these amortization of problems, is not really solving the recursion, but getting like a recursive formula for OBT plus K for some K in terms of OBT. And this is really easy because, well, if you want to do K is 2, so this would be like K equals 1. T plus 1, T. This is K equals 2. T plus 2, well, literally plug this in to here and you can check. You're going to get the following. And in general, you're going to just continue on to check this. Now, this is a fine and dandy formula, but if we modify this a little bit, it makes life a lot easier and quicker to plug into the calculator. Technically, you really know what you're doing. I've never went over this, but you can easily input this in the calculator. I don't want to get into that. I don't think there's a point. But anyway, so what I'm going to do is take this, and I should be clear. This over here is just the accumulated value of the coupons or K coupon payments of FR. All right. Yeah. So actually, before I do anything, I want to, I mean, this is just the math. The math is that this happens to be the accumulated value formula when you basically add this up using geometric series formula. that's not the best way to think of this. The best way to think of this, in my opinion, is kind of what we had before, and is that how much you owe k periods after time t is how much you owe after time t, or k periods after time t, the value, or that it's the value of how much you owe k periods after t minus the value of your payments, right? So you start off at time t. Well, what does your outstanding balance grow by after k periods minus how much the value of all your payments are? And that's exactly what each side of this is. You owe OBT after t periods. After k more periods, that grows to 1 plus j to the k, because j is your yield rate. So everything's growing by j times 100%. That's what the yield rate means. On the other hand, what's the value of your payments from t plus 1 to k? So remember, this is after, when we say OBT, it's sort of like you've already paid off that coupon payment. So we're looking t plus 1 to t plus k. We'll add all this up, you get the accumulated value. So I'm going to switch this to a formula involving present value and bring the FR SKJ to the left-hand side. And after multiplying, we get the following. This is really nice because what's on the left is the present value of a K period bond with coupons FR and redemption OBT plus K, right? FR AKJ is present value of coupon payments, K periods. This is just bringing back OBT plus K by K periods, or rather it's discounting OBT plus K by K periods. All right. And this is nice. You can plop this into your calculator very, very, very quickly and easily. And you like time diagrams. I love time diagrams. Here's a time diagram to illustrate what I'm saying kind of here. Right? So yeah, this is a bond-like situation. So the calculator can do things very quickly. And yeah, that's great. The not so great part about this and what I just did prior with the examples is I'm giving you more and more formulas to remember. Thus is life. Um, you know, yeah. And to me, formula memorization, as honestly, as a pure mathematician, that's the bane of my existence. Just memorizing formulas. I hate memorizing formulas. I'm terrible at it. If you're not so bad at memorizing formulas, not a big deal. Okay, so yeah, let's do an example here. And we'll have one more formula after this. Okay, so number 448. 12-year, 2,500 face amount bond has annual coupon rate. What the hell annual means in this context? Whatever. Paid quarterly, so you have to assume quarterly coupons every 3 months, and we're given nominal quarterly rates. So divide by 4 to get the actual rates for a period of 3 months. So the book value, remember that's just outstanding balance, after the 4th and 9th coupons are 209, 288, and 213, 231, 23, 16, 30, respectively. I can read, I promise. Calculate the amounts for accumulation of discount in the last coupon. So similar kind of thing we're going to do from before, in the sense of we're just going to write down what we're given. And this is great because we're given a lot of information here. We're given the coupon rate, face amount. We're given N is 48, 12 times 4. Because remember, periods are every 3 months. What quarterly means. So we're given everything here except the yield rate. Fortunately, what can the BA2 plus do very easily when we have bond-like situations? Calculate yield rates. So yeah, if you understand what I just said, basically what to do next is obvious. Write this, I'll even write everything down in this form to make clear what we're doing. Okay, so yeah, and I'm not right now, and I'm not going to use the outstanding balance formula that's from before the explicit formula. I'm going to use this recursive form here. Yeah, I'll go back to that in a second. Okay, so what am I getting? So first of all, let's get coupons. Why not? My coupons are going to be 2,500 times 0.0484. Again, this is like R4 as a nominal quarterly rate. Got to divide by 4, get my actual coupon rate. So calculator 100 times 0.0484. Yeah, one thing I want to mention is the solutions on the SOA website, the sample SOA solutions PDF. They get real wacky for these kind of problems. And I honestly, some of them I don't understand, like flat out don't understand. And I should understand it because I've taught this course. I got 8 on exam FM. I could have done better, should have done better, but whatever. Um, and I taught this course like a dozen times at this point. So yeah, so I can't make sense of some of these solutions. So hopefully my solutions make sense versus their solutions. Okay, anyway, these are my coupons. So what do I'm given OB4. Yeah, and I make a note here. I mentioned this a second ago. C is not counted when you're looking at PRN. I'll get to that in a second. I mean, it's obvious that that's kind of happening because otherwise you get numbers that are close to 2,500 versus close to something between like $7.77 and $31.35. But so yeah, we're given OB4 209288. And OB 19, 23, 16, 30. All right, so we have everything plopped into here. Right, so T here is 4. My K is 15, so that I have OB 19. Yeah, so 30, what 30, 25. I should be able to fit this. A for uh sorry, 1 second. Okay. Not T, it's K. Brain part there. Happens. It's like regular farts. They both happen. Yeah, we don't know what J is, so J is J. Plus, well, OBT plus K is OB 19, 23, 16, 30. 1 plus J to the minus 15. And that equals, I got room, OBT, 2092. So yeah, again, I'm doing this to emphasize we're in a bond-like situation. Don't you really could, if you just remember your formula, you could just pop into calculator immediately. That'd be a huge time saver. But 2092. Okay, so that means this is my present value. Well, I already have this number here, so let's set this to be payment. 2092.88 is my present value. 15, and my redemption is 23, 16, 30. Right. So remember, this is a time diagram. So again, this is a bond-like situation with this as a redemption. Fortunately, if we're given that, we can pop it into the calculator. So we have everything appropriately plopped into the calculator. Compute IY. We get this nice yield rate. I wish all yield rates were nice on exam FM. That would be good because that would indicate to you that you probably are doing things right. I like, well, I don't really do that on my exams. But 0.0206. So this is good. Now we can just plug and chug. Oh, not quite yet. So I do need to now use the formula, either one, for OB4 or OB19. I did OB 4. Why not? I mean, no good reason to use that versus OB19. Um, why is it really annoying me? Okay, so right, OB 4 is going to be FR 30.5 A N score. So you go back to the formula from 40206 plus we don't know what redemption is. Sorry. We know what this is, given this 29,280. This is what we're given. Blue, but whatever. 1 point, yeah, it's yield rate or discount factor to the again, and just plugging and chugging into the. Okay, so this is good. Got to figure out a better thing to do in the future, or there's no way in hell I'm re-recording these videos. But okay, this is all right. So clear TVM. This is my yield rates. 22. Yeah, I might as well just solve for redemption. I mean, it's easy, but why not? Um, This is present value, 30, 25, payment, 44, and yeah, and yeah, it's really bizarre that you get this really nice yield rate and this really nice redemption. I don't know why I chose to do it for this problem. Everything comes out really nicely. This 3,000. Okay, now we're basically done finally. Because now yeah, now I have everything to plug and chug into my formula, amount of accumulation of discount and last coupon, principal or paid formula. Just remember it's really going to be negative, whatever. Yeah, I'm just literally computing, so it doesn't matter. So I guess um well, I mean, I'm gonna get a negative answer here. That makes sense. It's gonna be negative 30, 25. That's FR minus redemption CJ 0.0206. Um yeah, so let me just write this down. So it's N minus T. So usually you would have a plus C here, but as I mentioned, they don't include that in the formula. So let me remind you, what's the formula? Right. So yeah, no formula here. So sorry, it's 48 minus 48 plus 1, 47. Um, so yeah, they're not including this. And again, how do you know if that's confusing? Well, if you did include it, you would get something pretty darn close to 2,500. You, you don't. You don't get anything anywhere near 2,500. So that's how, even if you had to guess, okay, it kind of makes sense. I would, yeah, if I was doing this on Exam FM, I would guess maybe they don't include it. But well, you're not guessing if you watch this video. Remember, don't include it. Oh, okay. Uh, Actually, uh this is gonna be 48, not 47. You would include it if it was 47. And yeah, so remember it's N, sorry, N minus T plus 1. So it's just one. Okay, so let's finish it. Going 30, 25 minus 3,000 times 0.0206 divided by 1.0206, and lo and behold, 3091 is D. 3090. Again, this is negative. It should be negative. Principal or paid is negative. The accumulation of discount is how much more your outstanding balance grew by. That means principal or paid is negative.